Thank you, and thank you to C3 for inviting us to share our story at Flint Hills Resources. Goose and Maverick are a tough act to follow, so maybe we'll call ourselves the three amigos. But when you think about an industrial facility, detecting and resolving potential issues early has always been valuable. It's been worked on for decades. It's part of what I did as an engineer right out of school. And the challenge has always been the manual and quite person-dependent effort that it takes to do that. So today we're going to give you a view into Flint Hills Resources' journey with C3 AI to transform how we detect anomalous behavior in our processes and equipment, and how we're trying to integrate that into our workflows. To give you some context of who we are, Flint Hills Resources is a petrochemical and refining company based in Wichita, Kansas, with refining centers in both Corpus Christi, Texas, and Pine Bend, Minnesota, just outside Minneapolis. We've got about 3,000 employees and roughly 4,000 miles of integrated pipelines and terminals operations to supply feedstocks to our refineries and also to deliver products to our customers. Our operations run 24 hours a day, 7 days a week, 365 days a year, and our planned maintenance events for major pieces of equipment are on the order of every 4 to 10 years. So reliability and predictability of our asset performance is incredibly important. And downtime drives all of our business measures the wrong direction, whether that be financial or from a stewardship perspective with environmental health, safety, impacts to the community, other things like that. So back in 2017, when we started our transformation journey, we got a group of operations leaders from across the company together in Wichita to talk about what does the vision look like? What are we really going after here, and what are the elements that would make up our transformation vision? We originally started with 8 elements, and we've narrowed them down to the 4 that you see on the screen. We need data that is connected and available to be used. That data needs to be contextualized and organized and accessible and related with other data to make it into information that then can be consumed. Then we can apply analytics to identify patterns and generate new insights and generate recommendations. And finally, you can automate workflows from those analytics and those insights to drive new value for the organization. And once we had aligned on these vision elements, we started talking about what capabilities within our organization would be needed to drive toward that vision. We started out with some key service businesses. Some of them existed already. Our asset management capability that focuses on maintenance and turnaround activities within our facilities, process control, and field operations were already parts of our organization that could drive transformation down into the field. But we also needed to create a few new capabilities in our organization. One we created was process and equipment monitoring. It's one of the first service parts of our organization that really started to drive transformation. We'll talk about that one a little bit more in a minute. We also created Field Data Solutions, which is focused on gathering data. One of the things in refineries historically is gathering data. As much data as we have, there's still more data to be had. There was an awful lot of data collected manually. Field Data Solutions is focused on automating that data collection and getting it into our systems. Then we created a data management capability to integrate that data, make the data flow, and make it accessible to the organization through our systems. And finally, we established a data analysis and modeling capability to enhance our ability to apply traditional methods such as engineering calculations and statistical methods, as well as newer technologies such as machine learning and deep learning. So one of the first areas we decided to apply our capability model was to our asset health and availability by early identification of potential issues. So the curve you see here is a general representation of asset health over time. So there's a natural degradation, and historically, with the manual methods we had in place, someone like myself as a young engineer would go out, gather data, analyze that data, and then make a recommendation on doing some work, based on what you saw in the data. But generally, we were pretty far down that degradation curve before we could really predict a potential failure. So the process and equipment monitoring team was generated and created to apply technology to provide us time, to buy us time through analytics and earlier identification of these issues so that we can either, one, make an adjustment to the process and eliminate the potential failure altogether, or two, buy ourselves time to do a planned maintenance outage that has the appropriate scope of work and or up to and including redesign of the equipment to avoid the failure mode in the future. So back in 2023, well, earlier we had started to establish this monitoring capability with purpose-built tools built specifically for condition monitoring of the equipment. And what we realized in 2023 was there was an opportunity there to combine the different tools we had for monitoring, and not only do that, but provide a platform to integrate the monitoring workflows with other workflows. So our overall monitoring and anomaly resolution workflow starts with identification of the anomalies. That's the monitoring team. But also, we need to flow into the diagnosis, prioritization, and resolution steps of the workflow to actually create the value at the end of the day. And that's where we started to look at applying this platform into other capabilities. And that's where John's team took over.
Thanks, Dave. I think it's important to note that there are no new principles in play here. There's no new problem statements in here. We've been working on these types of problems for a long time. A short 35 years ago, I was a graduate student at the University of Wisconsin-Madison, working on a research grant from General Motors, and we were trying to detect the incipient stages of machine tool chatter. We built some pretty sophisticated models. This was a engine block valve seat machining operation. We were trying to build some models, and we were pretty successful in creating the analytical models. But we lacked the compute power to actually see all the data relationships and all the patterns, right, that we were looking for to truly optimize the cutting operation. It was an anomaly detection use case. We had vision, but we lacked a path to get there. It was pre-big data. It was pre-Internet of Things. It was pre-elastic cloud computing, and obviously pre-AI. Fast forward to Transform 2024. I'm sitting in the corner the first morning after returning to asset management after a career of doing other really cool things. I'm back in asset management at Transform, listening to that first morning of all the presentations and being inspired by all the stories of users and some of the C3 members. After Lila's fireside chat with Duke and Dow and Shell, I leaned over a colleague at Flint Hills and said, we need to do this. We still had vision, but now we had a path to get there. So what has the last 12 months looked like for Flint Hills? First of all, I think it's important to note the refineries generate a ton of data. Most of it stranded data contained in various software applications designed for a specific business need. Traditional data strategies developed for a traditional organization. But as we integrated our capabilities, we recognized we needed integrated data strategies on a technology platform that enabled us to unify our data to enable core work processes. As Dave shared, the monitoring capability had a jump start. It started in 2023, working anomaly detection. But we create little value just detecting the anomaly. We've got to have an efficient and effective way to resolve that anomaly. And obviously, it's been spoken of this morning, lots of dollars in play in this space, but also lots of environmental health and safety benefits as well. And the work we were doing here directly benefits our stewardship objectives. So thinking about the value of early anomaly detection and thinking back to that PF curve that Dave introduced, detecting a problem early does little to impact business results if the anomaly sits in a backlog awaiting manual data collection, time-consuming analysis of the data, and very skill-dependent troubleshooting. What we believe, to efficiently and effectively resolve anomalies, we need to flow the pertinent information to the user, to the troubleshooter, on a platform, basically on a common platform like C3 reliability. And then embedding generative AI in the anomaly detection and resolution workflow takes us one big step further by enabling additional questions, right? I can ask additional questions. I can explore deeper into the data in ways I couldn't before. It also helps us level set our ever-changing skill levels of those folks responsible for troubleshooting the anomaly, as we have new people coming into the organization that don't have all the context of those that have been here for a while. Today, Flint Hills is leveraging Gen AI in a chat interface in our fixed equipment use case, and I'll talk more about that in a bit. Our vision, though, is to leverage Gen AI, basically embed the Gen AI and leverage it to anticipate questions that the user is going to ask and flow that information to the user, again, all on a single pane of glass. Dave?
So John's been talking about how we're applying AI in this space, and we thought it would be worth taking a step back and just looking at a mental model that we've been using since the beginning around just application of AI in general. We started this with the monitoring capability, but as we've moved into other areas, we started to see that this same mental model really applies no matter what area you're operating in. So when you look at this mental model, you start with measurement or creation of some kind of data. You organize and collect that data and get it useful into a useful format. And then you can do data analysis. Data analysis today can largely be automated. So this is the one area where we see the analysis being largely replaced with AI, or at least computing. To a large extent within FHR, when we say AI, we just mean a computer's doing it, a person is not. So we don't try to get too cute around the term AI, but when we get downstream of the data analysis step, it's really about automation. And it comes down to, can you build that knowledge that an SME would have to make a judgment and a recommendation into a system? Can you then build business rules into a system that would say, hey, based on that recommendation from that SME, I would make this business decision to create the most value for the organization? And then finally, can you automate that action at the end of the day? But in all of these steps, the key thing is to leverage AI where it is advantage versus humans. We don't want to just go apply AI to apply AI. We want to apply it where it adds value because it's comparatively advantaged to do so. We're also taking the approach to integrate data as we go, stepwise. So use case by use case, looking for areas where we can find steps in the process to automate. I heard the guys earlier talk about that. Find steps in the process where you can automate it, and then go after that, try to automate it with AI, leverage your data, make big steps, and then let it build like a set of Legos, building on itself toward your vision state.
So we came out of Transform last year with 3 different use cases in mind. Some people say pick one, we picked 3. We had a lot of ideas we wanted to explore, and we wanted to make sure we weren't hanging our head on just one experiment or one pilot that would affect our point of view one way or the other. We wanted to give the technology a good scrub. For each use case, the selection process was pretty clear. We said, okay, where do we doing work today in the company that creates a lot of value, that we really value the work, and then also happens to be highly manual and very manual and highly data intensive. So we value the work, but it's very manual, very data intensive. And from there, essentially, our objective was, for each use case, the objective was really to learn with the objective to scale. And I think this is an important but a subtle point. If you're only doing the pilot or the experiment to learn, a small scope or a small part of what it takes to actually do the use case, you're missing opportunities to along the way, right? That'll come in handy as you're going to scale. For example, right, if you're just dipping your toe in the water, right, to check the temperature, nobody's asking the question, well, how deep is the water, right? We're not thinking big picture. So we tried to apply this thinking by picking challenging data sources and large-scale integrations that would really challenge the platform. An example, our fixed equipment Gen AI use case takes on some of our most challenging data set in the refinery that we had. So we pulled that right into one of our very first pilots. So just briefly touching on the 4 use cases. Our first one we talked about already in play, anomaly detection. We started on that in 2023. Anomaly response, that's all about efficient and effective anomaly resolution that we've talked about. And then we had developed a use case called Gen AI for fixed equipment. And that was where we really wanted to tap in to the power of generative AI. And then lastly, we wanted to do a spare parts use case that really helped us think about spare parts prediction. And then we were leveraging our work order data and our parts inventory to create actual spare parts predictions. As we evolved our use cases, we recognized that we saw benefits across the use case. So we started to see beneficial overlaps across the use case and also data synergies as we evolved our mental models. And this enabled a shift in our vision from an individual use case value prop perspective to a more impactful end-to-end enhanced anomaly resolution workflow to fully transform the work. So going from individual use case value props to, hey, we think we can transform the work across a whole workflow. And you can see where we saw the initial use cases landing. This also, not only helped us see the big picture of what we're trying to accomplish and where we're going, but it painted a roadmap for, okay, which use cases should we do first relative to this roadmap and in what order? Also, a learning would be front-end loading the data to support upstream steps of the workflow, enable downstream steps. We found benefits in just front-end loading the data because the folks downstream in the workflow found new use cases that we hadn't considered in the original use case objective or target audiences. Talking a little bit about generative AI, this is a fixed equipment, generative AI. This particular use case is being led by Mark Geisenoff. He's in the audience today. And by the way, Pine Bend is celebrating its 70th anniversary this year. We have some process units that have been in operation since 1955. We have inspection data going back to when those process units were first started up. For years, our fixed equipment data was captured with handwritten notes. Depicted here on the screen. Eventually, these handwritten notes became typewritten notes. In 2019, we scanned all this paper data into large PDF files when the inspection team went fully digital. Okay? So just to give you a sense of what this looks like from a size perspective, we're talking about 3 million pages of text, all unstructured data. So when I mentioned we took on some challenging use cases, this was a pretty good one for us, right? This is a pretty good challenge. This not only transforms the way our fixed equipment inspectors do their work, in particular around scoping turnarounds, but knowing how this use case works benefits that anomaly detection workflow that we talked about, the entire workflow all the way through resolution, as well as what other Gen AI ideas we can think up in Flint Hills. So this was a really good use case for us out of the gate to really help us understand how do we best use the technology. A closer reveal of the C3 Gen AI capabilities really demonstrates its amazing ability to transform the work. To provide some context, our fixed equipment inspectors typically spend months scoping turnarounds. It's a very laborious process, digging through those files that I mentioned earlier. For the benefit of the broader audience, refinery turnarounds, those are large maintenance events. We do those over about every 4 to 10 years, depending on the process unit. Understanding the various corrosion and cracking damage mechanisms in, for example, a pressure vessel is vitally important to our success. Again, we're all about containing the process. We've got to maintain the sanctity of that pressure envelope. And it all starts with making sure we understand those damage mechanisms and we've got the right scopes to manage them. Oftentimes it's repair, it could be replacement. We've got to be solid in that space. Given the consequences of being wrong, and you saw the data, what that looked like, this is not a casual Gen AI use case, right? This is a real deal use case. And our fixed equipment inspectors, rightly so, are pretty demanding customers. They want to make sure we get it right. The detailed evidence package that the C3 Gen AI provides, together with the document excerpts and the ability to drill in, asking further questions, really is meeting their needs. I'd say it's created tremendous work efficiencies, but more importantly, it's freeing them up time to think of new vulnerabilities we have in our pressure envelope. I'm not spending all that time digging for data. I can spend more time thinking about, okay, where else do I have opportunity in this part of my business that's so cornerstone to our success? So really, in this case, Gen AI, it's reduced our scoping time from months to days, but more importantly, it's impacted our EH&S and stewardship objectives. So some progress to date. Where are we today? We're still pretty early in our journey. But I'd say in summary, after integrating our largest data sets from the refineries into C3, we've changed the work of roughly 50 people involved in the anomaly detection and resolution workspace. I say roughly because this number is increasing each week as more and more people ask to get access to the tool. So we're getting some good pull from the organization. A couple of change management themes here, as was hit on earlier today. We've tried to involve the people in the use cases that are most impacted by the changes, trying to get their input early. And often we did a soft launch in November before we stood this up officially in February. That being said, as much as I'd like to chalk this up to good leadership, bringing all the pertinent information that an individual needs to do their day in a common environment, it makes their job easier. If I can focus on what I'm good at as a human, what I'm comparatively advantaged to do as a human, troubleshooting, problem solving, analysis, without having to do all the laborious tasks that AI is comparatively advantaged to do, I tend to feel more fulfilled. So we're getting good pull, albeit, there's been some minor bumps along the way as people adjust to using the new tool, but in general, we're getting new pull. People are asking, hey, this is great. When can we connect this data? Or, hey, what about this? Or, hey, when do I get access to this tool? So we're encouraged by what we see, and we think we're on a good path. At scale, our numbers look something like what I have up above on the screen. We think these numbers are probably conservative. The number of users is likely very conservative, only because we get more people thinking of new use cases that we hadn't originally thought about, or new ways to use the data. They're already using the tools in ways we hadn't actually planned, which is a good thing. So I think our user number is low, but you get an idea of where we're headed.
So we've talked some about what we're doing, applying AI to that work process that John had up there that kind of includes our process monitoring and asset management workflows. And we've talked a little bit about why we're doing it, trying to extend the useful life of our equipment and ultimately increase utilization of the refinery assets so that we're running at full, at constraint, at optimum as long as we possibly can. I'm going to talk a little bit about how we're accomplishing that. And it starts with our talent strategy. So who's going to do the work? What are we going to do in order to be able to enable these capabilities, bring the data into the platform, and align that in a way that lets us create real value ultimately for the people that are using it? And the way we think about our talent strategy is applying all of those different capabilities that Dave had up on the board earlier. Those capabilities live in different organizations, but we think about how do we take the unique skills and abilities of all the different individuals that we could leverage on solving these really hard problems, put them into one team. Think about it as kind of one cross-functional, cross-capability team. Have them have a common objective, that we're all working towards, so that they're vision aligned, they've got the right mental models, they're working together, and then we assign responsibilities based on those individuals' comparative advantages in order to go get that one objective. As we bring our partners in, I totally agree with what Jim said earlier around not wanting to go the snowstorm alone. We partner with C3 in a very similar way. We take a look at what capabilities they're able to bring to the table, how can we leverage the skills and abilities of their team, and have that kind of fit into that one team mindset, again, with that common objective. And the way that we work looks really similar. We didn't compare notes with the Nucor team, I promise, but it looks really similar to the way the Nucor team kind of laid out their process. We start with scoping and discovery. We start to think about what are all of the ideas that exist that could help transform the work in a way that's going to create real value? What data are we going to need in order to be able to apply AI in order to change this work? Where's that data live? Does it live in one of our applications and it's relatively good data sitting there? Does it live in someone's spreadsheet, on their desktop because they enter the data every day? And they work that process? Does it live in a handwritten note somewhere that we need to be able to ingest and internalize and contextualize? Where's all the data live? And then as we bring that data together, we talk to our C3 team about what options do we have? What's the platform already do? What are the applications already enabled to do? What kind of looks like plug and play? What's going to take a little more work? What looks like enhancements? Where is the roadmap going? How long would we need to wait for the roadmap to get there for us to be able to take advantage of those features? And then what's maybe step out ideas that we could work on together to try to figure out how to solve? And as we go through that scoping and discovery phase, we start to frame up what that initial or pilot deployment looks like. And that's where we take a subset of the data, a subset of the equipment, kind of try to scale the use case into a solvable problem. Hopefully not pick the hardest problem possible. We do sometimes find ourselves looking to solve the absolute hardest problem right out of the gate. And we work our way through that pilot. We take advantage of all the different subject matter experts that exist in our business in order to be able to talk about what they do today and what they're trying to do in the future. Help us figure out what data we might be missing in order to be able to automate the workflow, apply AI, help us get to a better prediction. And then our C3 team members help us complete the initial configurations of the application, collaborate on our data science models. We get to a place where the initial pilot is looking pretty good, looks like it's going to work for that subset of equipment. We're ready to release. And then we get to what I've found to be our hardest phase, which is that enhance and scale phase. And when we were first starting to do this, I thought scale would look like we have a subset of data coming into the platform, just go get the rest of the data, unfilter the query, send the rest of the information in for all of the different pieces of equipment that we're trying to accomplish. I figured there'd be some performance tuning necessary in order to make it work, and then we'd be off to the races. And what's happened is really around that enhance idea. As we've put this in people's hands, like John was describing, the ideas come out of the woodwork. We've got a passionate organization that has a culture of transforming their own work and trying to figure out how to do things better, close gaps, capture opportunities, create more value. And so as people start to get a glimpse into what's possible and what they could do, we get a ton of ideas about what else we could do, what else we could add, how we could improve the way that it flows, how we could get more data or improve a prediction, add more context to a model. And so that's our challenge today, is how do we figure out how to balance the amount of new features that we build into this enhance and scale phase. Where do we just say, this is good enough, let's go create value with it on scale and open it up to new equipment. And how do we work our way through what's next? And it becomes this continual cycle of new ideas, new enhancement requests, new features that then we work with C3 on how do we bake some of those into the platform. Because ultimately where we're trying to get is to this final spot, sustain and improve. So we need to think about our technology assets, similarly to how the team is talking about treating our refinery assets. They all need reliability strategies based on the criticality of the work that they support. We need to monitor our data integration flows and make sure that the data's moving in the way that it's supposed to. We need to be continually improving our data quality so we get better outputs from our models at the end of the day. And then ultimately, we need to make continuous improvements to these applications because the work constantly changes. The business environment changes, the operating environment changes as work gets done in the field. And we need to be able to keep up with those changes in order to have something that lives for a long time and continues to create value. Because ultimately, we don't create any value or cash any checks unless we go change the work. And we need a sustainable way of changing the work for people to believe in it. So that's where we really think about how do we partner with the C3 team in order to have as many of the features that we value, that they believe their customers would value as well, baked into the base platform, so that reliability strategy, that sustain and improve, can come from both of our teams, not just us trying to maintain something long term. So a handful of lessons learned that we've kind of worked through. What we have found is that anomaly detection is a great way to start. Anybody whose job is to take a look at data today and think about how it compares to data yesterday or an hour ago or this morning, and imagine what it might do a day from now, an hour from now, later in the afternoon, benefits from an anomaly detection capability. They're doing anomaly detection, they're just doing it manually by pulling data together and applying their own knowledge as to what might be happening or what could be happening. And we found that that's a great way to get started on an AI journey. You're working with a new group, trying to get people connected to what's possible, automating the anomaly detection and giving them results that they're then able to apply into their work without having to go do all the data gathering and manual analysis is a hugely powerful way to get people started. And what it's done for us is it's generated a ton of new ideas as people start to get familiar with how that works. They see the anomaly detection, they start to imagine what else could be done in order to automate that workflow or improve the prediction or help make a better decision. And then they can apply that to that enhance and scale phase I was talking about, where we get more ideas, we think more about how we might be able to further automate the work. We get to a point eventually where you've got kind of John's workflow drawn up there, and we have a lot of different capabilities applied to it. Talk to them about this. Ultimately, the thing that creates value is something that's in production, running at scale, and being leveraged to change the work, to transform the way that we operate. So it's a big focus of ours to get to a sustainable place. It's a big focus of ours to get to a place where our teams are self-sufficient in leveraging the platform and being able to develop on it so that we can continue to improve the platform over time, improve and change the way that teams are working, and get to a point where more and more processes are integrated so that more and more processes benefit from the improved data and from the AI. And then lastly, we've found that it is really beneficial to have a partner when you're in that snowstorm. And so trying to spread out the amount of work that goes on in order to be able to create sustainable value, find partners who are going to build like C3 into their base applications, things that we can take advantage of. And then as enhancements come, as we were seeing in the product roadmap earlier today, think about how we can apply those enhancements in order to create more value for our work. And then it's two teams working in concert. You get aligned vectors. You get more output at the end of the day. I'm going to hand it back to John. He's going to bring us home here.
Thanks, Lucas. So in summary, we see great benefits in early anomaly detection and resolution. Our partnership with C3 has enabled us to challenge paradigms and see new value streams as we push the technology in ways we didn't originally see possible. We now see equipment life extension as a very achievable outcome to early anomaly detection, and significant benefits to the business as we bring to light new sources of otherwise unseen data on the C3 platform. So more of this story to come. Thank you.